So 6.2 is all about parallelograms. Make sure you get this in your notes as 6.2, parallelograms. So first, some definitions. A quadrilateral. So a polygon is a quadrilateral if and only if it has 4 sides. They don't have to be congruent, they don't have to be parallel. A quadrilateral is about as basic as you can get. And so a parallelogram is a special type of quadrilateral. A parallelogram is a quadrilateral, a quadrilateral is a parallelogram if and only if it has parallel opposite sides. So let's take a look at an example. So here we have a parallelogram ABCD. Actually ABDC, I guess I got those switched around a little bit. But if you take and drag the points B and C and A, you'll notice that these side lengths, 9 and 9, the opposite sides are always congruent. Likewise, if we change around the other sides, the opposite sides are always equal to each other. Next, if you take a look at the opposite angles, so 62 and 62, opposite angles are congruent, 118, 118. You'll also notice that these two angles, 62 and 118, they're supplementary. And that's true because we've got two pairs of parallel lines and cut by transversals, so consecutive angles are always supplementary. A and C are supplementary, C and D are supplementary, D and B, A and B. Last, take a look at these diagonals. So they're not congruent in length, right? Because right now it looks like AD is longer than CB. But what you should notice is that they bisect each other. So the distance from A to the midpoint, let's call it E, is 7. Let's just move that over there. And so the distance from E to D is also 7. From C to E is 4. And from E to B is also 4. And that's true regardless of what the original shape looked like. Let's try and move this around a bit. So the diagonals will always bisect each other in a parallelogram. So we have these definitions. A quadrilateral is a parallelogram if and only if it has parallel opposite sides. So from the previous, we see a couple of special theorems. Oh, by the way, we're going to abbreviate parallelogram with the symbol parallel and then the word ogram. So some theorems that we have from that GeoGebra video. If a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. Likewise, both pair of opposite angles are congruent. Consecutive interior angles are supplementary, and the diagonals bisect each other. And these are all theorems that we can prove. One last statement. If you have a parallelogram with one right angle, then it has 4 right angles. And that should make sense since opposite angles are congruent. If you have a right angle in one corner, it must be a right angle in the other corner. And since consecutive interior angles are supplementary, we've got right angles all over. So let's take a look at this example. Here we have ABCD, and we've got a couple of coordinates, and we want to decide whether this is a parallelogram or not. Well, we can graph it, and it sure looks like a parallelogram. But in order to verify it's a parallelogram, we have to check slopes, the slopes of opposite sides. So first, if I check the slope of AB, I see that slope is 5/3. Slope of CD is also 5/3, so therefore AB is parallel to CD. And then check the other pairs of parallel sides, BC and AD. I see both slopes are equal to 0, and so that means those are parallel as well. So since both pairs of opposite sides are indeed parallel, we know for sure that ABCD is a parallelogram. Let's try another one. Here we have a parallelogram on an XY coordinate plane, and we have the missing coordinates there. Well, since opposite sides are congruent, if this is 8 units long, and I know it's 8 based on the coordinates of that rightmost point, I know that this length is also 8 units long. Now, from that little point 3, 4, I know that this distance is 3 units. And so therefore, 3 units and 8 units together make 11 units in the x direction. Now, looking at the point 3, 4, I see that 4 indicates that this is 4 units tall. And so therefore, with parallel sides, that ought to be 4 units tall as well. What if we replace those numbers with variable letters? So now I've got c units, which means that's also c units. The AB point indicates that this length is a units long, so therefore the x-coordinate of the missing point must be a plus c. The AB point indicates that it's b units tall, so therefore the parallelogram is b units tall, b units in the y direction. Here's one that's slightly different. Here we've got the missing point, but it's a different point. It's not the rightmost top point. Pause the video and give it a try. Well, let's see. We know that this length is 8, and so that length is also 8. However, the entire length here is 11 units long, and so the difference should be 3 units for the x point, the x coordinate of the missing point. Then, because this is 6 units tall, I know this has to be 6 units tall as well, so you should have the coordinates 3, 6. Now let's take a couple of proof practice problems. So first, prove that if a quadrilateral is a parallelogram, then a diagonal separates the parallelogram into 2 congruent triangles. So let's start off with the diagram. We know the if part of this sentence says if we have a parallelogram, then a diagonal, so we want to prove, let's call this ROCK, we want to prove that that diagonal creates 2 congruent triangles. Well, how do we prove anything about triangles? Is with side, 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 angle, side, angle, and angle, angle, side. So we have a parallelogram. Parallelograms have 2 pairs of parallel opposite sides. So for example, RO is parallel to CK, which gives me that those 2 angles must be congruent. Likewise, the other pairs of sides are parallel, and so we've got another pair of congruent angles. Now with the shared side up the middle, we can use, no, not SAS, we can use angle, side, angle to prove that these 2 triangles are congruent. So we know we're dealing with ASA. We had, let's see, the shared side, OK is congruent to KO. Now let's say, well, we've got the green angles and the red angles. The green angles, ROK and CKO, came from the fact that RO was parallel to CK. The red angles came from the fact that RK was parallel to CO. And now the only difference from this proof and previous chapter's proofs is we were given that ROCK is a parallelogram. And parallelograms have parallel opposite sides. And so that's our proof. Let's take a look at this next proof example. If a quadrilateral is a parallelogram, then opposite angles are congruent. So let's say DUCK, duck, is a parallelogram, and in order to prove this general statement, we want to prove that D is congruent to C. Well, we can actually use the theorem from the previous proof, right? Previous proof said that parallelograms have 2 congruent triangles if they're split along a diagonal. And so that previous proof allows us to say that the red and the blue triangles are congruent. which means that opposite angles must be congruent. So we know we've got a parallelogram, and that previous theorem states that the two triangles created by the diagonal, the two triangles are congruent. Therefore, if the two triangles are congruent, all of the corresponding parts of their triangles are congruent as well. So it's a pretty quick proof using the previous theorem.